Hi, welcome to Weather Patterns 1.5. This is our fifth lesson in Amplify, going along with our Weather Patterns unit. So I want to remind you before we get into the details of this lesson how these videos are supposed to work. You're supposed to open up two tabs. One tab will be this video that you can play along, and if you want, you could probably shrink it and move it to the side so you can see it all the time. The other way, you're supposed to open another tab where you're going to go to Amplify. And there you'll log on and you can have the video going and Amplify at the same time so you can kind of follow along as we go through this lesson. So with that being said, we are moving into Weather Patterns 1.5. Well, as always, we're going to be in our warm-up. So let's go ahead and go to tab 1. And we are moving into energy. And so go ahead and fill out your warm-up. And of course, since it is a science class and we are going to have our science song playing. And if it doesn't get stuck in your head by now, it will be. So go ahead and jump in to lesson 1.5, tab 1, the warm-up.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth.
Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know it's the water cycle happening again. Evaporation, condensation, precipitation.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth.
Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know it's the water cycle happening again. Evaporation, condensation, precipitation.
The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. Evaporation comes when the heat from the sun warms up all the groundwater, then it turns to water vapor. Condensation takes over, it goes up to the clouds. Water vapor cools down and it changes to a liquid now. Precipitation happens when the drops get big. It falls like rain, snow, sleet, and hail upon my head. I know. It's the water cycle happening again. Evaporation, condensation, precipitation. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth. The water cycle takes the water and moves it up and down and all around the earth.
Well, after listening to that song, I'm really hoping at this point it is well driven down into your mind and it is constantly. In fact, you might be even dreaming about it at night, thinking about the water cycle. go, what? Well, at this point, you should have finished your warm-up. And your warm-up, you looked at these 3 different sizes of clouds. And in the photos that you looked at, which cloud shows the most cooling or the most energy transfer? Now, I think the best argument would be for cloud A. That's a type of cloud called a cumulonimbus cloud. Cumulonimbus clouds are very common when they make thunderstorms. They are the really tall, very big thunder, fluffy clouds that you see in the summer when you have a lot of hot and cold mixing. So you have a lot of energy being transferred out to cooler air, which we'll talk more about as we move through this lesson. Well, today we are going to be spending this next little bit of time looking at and answering this question. Why do some clouds rain and others don't? You know, here in Oregon, we're, again, really familiar with clouds. Sometimes it could be a really dark gray day and it doesn't rain at all. Other days, maybe it's partially sunny, but we get lots of rain. Why is that? Why do some clouds give us rain and others are just clouds? Well, today we're going to be exploring that. We're going to be looking to answer that question when you finish this lesson. Now, in lesson 1.4 of Amplify, you read about Dr. Joanne Simpson. Dr. Joanne Simpson was the very first PhD meteorologist in America. She spent a lot of time looking at the layers of the atmosphere and exploring what made clouds. Some of her work was fundamental in our understanding on how clouds form. So I want you to look back through your article. I want you to hit pause here in just a second. And I want you to look back through the article and kind of review what were some of those big annotations, one of the big things that you learned as you read about this. Now, coming back, I also want to take a little bit of time to look at someone on the other side. You know, many times people don't think that art and science really go together. They like to make the argument of like left brain, right brain, and really that's not real. Science and art has always been together and we're very closely linked. Creativity and exploring the world are really very similar traits. So instead of just talking about scientists who explore weather like Joanne Simpson, Dr. Joanne Simpson, I want to show you an artist. An artist who is able to use clouds and use the science of clouds to create clouds of artwork. So I'm going to show you a video clip. This is a video clip from a German channel called DW. And I'm not going to try and butcher it, but it actually translates to the German wave. And Euromax is kind of like their lifestyle part of their online TV show. And I want to show you an artist called Bernard Smilde. He's Dutch. And he uses what we've been talking about in this class about condensation to create clouds as a form of art. So I want you to just go ahead, put on some headphones, or just sit back and enjoy this next little thing about the artist Bernard Smilde. Now you can see in this video, he's using condensation. He's using cooling. He's using water. It isn't just smoke machine. A lot of people as we watch this video think, oh, it's just smoke machine being released. No, he is actually using condensation and the scientific principles of cloud formation to create a cloud in these spaces. It's pretty amazing. And he gets paid many thousands of dollars for each one of these little art installations. We can use this idea and his understanding of what you just saw with Bernard Smilde and what Dr. Joanne Simpson was showing us to understand how clouds form. And as we continue, what makes a cloud rain and what makes a cloud just a cloud. So let's take the art of Bernard Smilde and the science of Dr. Joanne Simpson and let's combine them. We're going to go to the lab, aka my kitchen, and we're going to do an experiment with the bottle. Now this is not an experiment you can do at home, but we're going to see if we too can make a cloud inside a specific space.
All right, well, today we have an experiment that is a little bit dangerous, but not really dangerous. Everyone here is safe. I wouldn't put my daughter's life in danger. But
kind of scared of them.
Yeah, you should be scared at all. It'll be fine. Especially that we wear goggles and we're wearing more safety. So this time today, it's going to be really important that we keep all of our safety equipment on. Now, in our last week's experiment, we created condensation in a bag, which was kind of cool, right? You remember?
Yeah, remember? It's too thirsty. I look at water.
Yeah, we made you thirsty. Well, when we saw though, there was water inside your breath, and when we cooled it in the refrigerator, that water turned from a gas to a liquid and made condensation. Well, today we're going to take this to a little bit further extent. And instead of just making condensation, we're gonna make a cloud inside the bottle. Now
That's a soda bottle?
it was a soda bottle, but we drank all the soda.
Nobody knows that.
Yeah, it was pretty good. So today what we're gonna do it twice. And the first time we're gonna do it,
Maybe cut it in half with a straight-out knife.
well, we don't actually need to cut it. We'll just use it over again.
Yeah, with a bike.
Yeah, so for this experiment, you're absolutely right, Avery.
With
So,
the highlight.
just listen, Avery, this is a bike pump, and we're gonna use that to make more air pressure in here, which is gonna raise the temperature. And when you increase temperature, hold on, we're gonna cause evaporation.
Yeah.
And then
It
eventually, it's going to explode, and it'll cool down. And then when it cools down, we're gonna get condensation. So a cloud, though, is more than just condensation happening in the air, liquid water. We also need something for it to stick to. So let's go ahead and let's make our first cloud in this bottle. So we're gonna start off by adding some water, because clouds are water. So Avery, can you help me out? Will you pour water inside our funnel here? Yeah, you don't need your goggles quite yet. No, yeah, just pour it all in there. That's perfect. Now most of this water, oh, that's quite a bit of water. Most of this water is going to stay liquid, but we're going to get enough evaporation to happen in here that it's going to actually make a cloud.
Have a measure dough right here.
Yeah, part of the label stuck. But a cloud also needs some things for that little bit of water to stick to. Now in the air, that's dust particles, but we don't have a lot of dust here right now. So instead, we are going to use smoke. And so we're going to actually, this is a goggle here. Put your goggles on. There we go. Now we're on to safety. So we're going to add and fill some smoke up into this for that water to stick to when we make our cloud. So this is where things get a little bit dangerous. So we're going to get this paper burning. In my classroom, I usually just use a match, but this will work just fine. Now, I know you can't see it, but there is actually smoke particles inside this bottle. So you can smell it. Can you smell the smoke? Yeah, it smells like smoke. So we're going to create our cloud. And so Avery, this is where we're definitely going to need those goggles. We're going to increase the pressure. Whoa, that was close. And then,
I have smoke from my roof.
and eventually the pressure is going to get so high that the top is going to blow off. And then when we do that, look inside the bottle, you're going to see the cloud. So let's hold this for me here. Remember, we're going to keep this away from your eye. Yeah, hold it down hard though. All right, here we go. That's better. Okay, eyes back.
I gotta pee right now.
Now you can come in close here. You can see, kinda, there was a cloud in there, and it dissipates pretty quick. That's pretty exciting, right?
Yeah, I kind of know that you gotta get hurt down.
Oh, I'm not gonna get hurt. Now, one thing, hold on here, let's get all this water out. So we emptied out the water out of this. And you know, water actually has a really high temperature of evaporation. And so we didn't get a very nice cloud in here. It kind of went away really fast, disappeared. But if we use something like
Using alcohol?
rubbing alcohol, yeah, if we use rubbing alcohol,
Explode from a roof to a top, then come down to our head.
well, you're absolutely right if we use fire, and we are not going to use fire for rubbing alcohol because it's very flammable. So instead,
It's very dangerous too.
it is. So instead, we are just going to use air pressure for this.
Got smoke from
So-
our house. We did that.
So instead, we are just going to pour in some rubbing alcohol. And we don't need that much rubbing alcohol for this.
Okay, no.
Yeah. And we're going to do the same thing. We're going to add air pressure to it. When we add air pressure, that's going to increase the temperature, increase the energy, so that this rubbing alcohol is going to evaporate and form a rubbing alcohol vapor inside of it. And eventually, when that top blows off, the temperature is going to cool really fast. All of that vapor is going to condense into liquid rubbing alcohol, and we will have a rubbing alcohol cloud inside our bottle. Should we do it? Yes.
I smell it.
Yeah, it definitely is rubbing alcohol smell, isn't it? It smells like a good smell. All right.
I want to blow my nose with this.
Well, now you can't come out now. So let's go ahead and put your hands on here again. Let's hold it. Okay, remember, head away from it. Perfect. Here we go. Keep it down.
Mom, no, Dad didn't do the electric. Dad, he don't how to do the electric.
Starting to go. Now, in fact, if I do it right, I can, we'll pour out rubbing alcohol. But I can also pour out rubbing alcohol clouds. Now, it's not exactly water cloud, but it's the exact same process. But a cloud is caused by water vapor condensing in the air in the droplets.
Oh, yeah, it's rubber.
Okay, you're right, that are light enough to float in the air. There's enough pressure to hold them up and you get a cloud. Well, in this case, it's a rubbing alcohol cloud.
Now, what I would like everyone to do is to go to tab 3. Now, in tab 3, we are going to use the sim to model the exact same thing you just saw happen in the lab. There we use rubbing alcohol and water to create a cloud inside a bottle. We increased the evaporation by warming it up by putting in air pressure. It made more energy, more evaporation, and then we quickly released the energy and all either water or rubbing alcohol condensed to form a cloud when we had condensation. So we're going to see very much the exact same process using the sim in tab 3. And so I'm going to go along and give you the first set of data, and then after that you're going to have to build your own weather events following those instructions that you're going to see on tab 3. So let's go ahead and bring up the sim. So here is our sim. Now for this today, I'm going to do the first trial of it, and you are going to do our last 2 tests where you're going to be changing the water vapor and the air temperature. So if we can see trial 1, it wants us to set the surrounding air temperature to negative 20 degrees. So I'm going to take this cursor right up here and I'm going to move it now to negative 20 degrees right there. It also wants us to make sure that the air parcel is at 25, and that's already set for me, so I don't need to change it. If I did, it would be right there. And last but not least, I need to put the water vapor in between medium and high. So I'm going to set it right there in the center. So I have everything set up to run my very first test. So when I'm ready, I'm going to click over here on Run. And you can see I've got energy transferring out. Those arrows are showing us that energy is transferring out. And we have rain falling. And rain is falling out of our cloud. And you notice our cloud's getting a little bit smaller than when it was at some point, because at the beginning, because water is leaving our system. So once we've run our sim all the way through, you can see the Analyze button up here is blinking. So I'm going to hit Analyze, and it's going to give me all the data that I need. So you can see we have starting air temperature, final air temperature, the difference, the energy out, the amount of water that's in water vapor that's still in the air. We have the amount of water that's in the cloud. That's the actual water, condensed liquid water in the cloud, and then water that rained out. We can see we also created a level 1 rain event. So let's go ahead and jump back into Amplify and put this data into our data table that you'll find on tab 3. Oh, there it is. I just had it preset up. So we started off with a surrounding air temperature of negative 20 degrees Celsius. Now I'm not going to put in the degree symbol. I'm just going to put a C so that I know that that temperature is in Celsius. We know that our air parcel started off at not W, but 25 degrees Celsius. Now if we do some math, we can see 25 minus a negative 20 ends up being actually adding 20. So we changed a total of 45 degrees Celsius. Oh, I'm sorry. I messed up there. The final air temperature, I got to read what's in front of me, is negative 20 degrees Celsius. We reached equilibrium. So that air parcel reached equilibrium with the surrounding air. There we go. And our difference was 45 degrees Celsius. So that we changed a total of 45 degrees. And that equaled an energy out. Now, if we go back into the sim, you can see right there it says 99 megajoules. You can see that number right there. 99 megajoules. And a joule is an amount of energy, and mega is a million. So that's a huge number of energy that was transferred out of our cloud in the form of condensation and rain. So there is our rain for our first trial. Now, you are going to do the same thing, but this time you're going to try and create a cloud that has no rainfall. So you're going to want to get a rainfall of 0 when you end this. Then you'll record the starting temperature of the surrounding air, the starting air parcel, the final air temperature that you started with, and the difference, and then the energy that transferred out. And then the last one, you're going to want to create a giant rainstorm, a 3 and a 4 level, using what we've been learning about condensation and energy transferred out. Go ahead and give that a try. So, what did you see happening in the sim? Now, if you noticed, it should look a lot like our thermal energy unit. Now, when you had a warm air parcel, it has a higher amount of thermal energy. And energy transfers from high to low. And so energy was being transferred out of our warm air parcel to the colder surrounding air. The colder the surrounding air, the more energy that will transfer. Or the warmer the air parcel is to the colder the surrounding air, the more energy transferred. So as that air parcel rose up in the sky, more energy is being transferred out, and it is cooling down. That leads us to key concept 3. Energy will transfer from warm to cold air until the temperatures become equal. Now, if we think back to thermal energy, really that sounds familiar, and we can rephrase it. That energy will transfer from warm to cold or high to low until it reaches equilibrium. So an air parcel will transfer energy out to the surrounding air until it reaches equilibrium. Well, and that's happening when energy is being transferred out. That leads to condensation, which leads to our 4th key concept. Key concept 4 says the more an air parcel loses energy and cools, the more rainfall that will occur. Put it another way, the more energy that transfers out, the more condensation. More condensation means more rain. So, if you want a really large rainstorm, you need really warm air in an air parcel and really cold air in the surrounding. And when those two transfer energy between them, so when that air parcel gives energy to the really cold air around it, it's going to lead to lots of condensation, lots of liquid water. Eventually, that's going to lead to lots of rainfall. So let's go back to that investigation question that we set out to answer at the beginning of this video. Why do some clouds rain and others do not? The answer comes to how much energy is being transferred from the air parcel to the surrounding air. If there's a lot of energy being transferred, that means there's going to be a lot of condensation, and the water that condenses will move past just being a cloud and fall as precipitation. If there isn't a lot of energy being transferred out, meaning that their temperatures are pretty close to themselves, you might get enough condensation to get a cloud, but you're not going to get enough rain. So, why do some clouds rain and others don't? It depends on the temperature difference, the changes in the temperature, or put it another way, the amount of energy that's going to be transferred out. Lots of energy being transferred out, lots of condensation, lots of rain. To wrap this lesson up, we want you to do tab 4, that homework tab. Now you're going to do it. It's another little experiment with the sim, but it shows us that you understand how energy and leads to condensation, which would lead to precipitation. So go ahead and finish this up by going tab 4. Now, before you do that, I want to remind you how these videos work. Remember, because these videos go really fast, you can always hit pause, you can always go back and rewatch something to make sure that you understand it. Sometimes you might have to watch the whole video again, but making sure that you understand what we're trying to understand. And in this case, it's that why do some clouds rain and others don't? But even when things get hard, remember, in science, to always keep moving forward.